Swayam Prabha. Digital India. Educated India.
Last class we looked at the classification of the joints as basically the fibrous type of joint. So, based on the construction of the joint as the fibrous type, such as the ones found in the skull, which allow basically no movement between the bones. Then the second type, which allow a little bit of movement, are the cartilaginous joints, which are like the joints between the thick fibrous cartilage between the vertebrae and also the pubic symphysis, which allow a little bit of movement, but still it is not a whole lot. All the movable joints in the body are the synovial type of joints, which have a capsule, which also have synovial fluid, which lubricates the motion between the bones, and that is and there are so many of them that they can themselves be classified based on their function. So, different synovial, there are different types of synovial joints which can be classified based on their mechanical function, mainly what kind of movements they would allow at the particular joint. So, today we will look at these types of joints. So, let us look at the types of synovial joints. So, we look at, say, if you look here, you can, these are the types of synovial joints. You have what is known as a ball and socket joint, similar to what you see in engineering. In engineering systems, you have ball and socket joint. You have a ball that moves inside a cavity, and it basically will allow rotation in 3 different directions. Then you have what is known as a condyloid or ellipsoid joint. This is similar to the ball and socket, except that the shape of the ball, it is more like an ellipsoid, and therefore, it will only allow motion in 2 different planes. It will not allow motion about the longitudinal axis of the joint. Then you have a special joint called a saddle joint, where you have these 2 surfaces that interface in this manner, and this also is a joint that will allow rotation in 2 different planes. And then you have the regular hinge joint, similar to a mechanical hinge joint, which will only allow rotation in 1 plane. Okay, a hinge joint will only allow rotation. So, if you notice, most of the joints in the body are joints that allow rotational motion. Okay. There are a few joints that will allow gliding motion, translational motion, but the majority of the segments move about one another in rotation. So, you will notice that most of the joints are joints that allow rotational degrees of freedom. Then another type of joint is what is known as the pivot joint. So, the pivot joint is also like a hinge joint, except it is in a different plane. So, it is called a pivot joint when it allows the motion about the longitudinal axis. That is the only difference between the hinge joint and the pivot joint, but it is given a special name because of certain locations in the body where the motion that is allowed is the motion in the transverse plane. So, let us look at each of these a little bit more closely. Okay, we will see where you can find these. So, If you look at the ball and socket joint, the most common examples will be at your shoulder and then at your hip. So, you have here at the shoulder, this one does not have the, it does not show the socket very clearly, but at the shoulder the clavicle forms a small, it has a small cavity into which the ball of the humeral head goes into it. Okay. So, that articulates with the socket in the scapula, with scapula to form the shoulder joint. So, that is a ball and socket joint, and that allows shoulder motion in shoulder rotation in all three planes. So, I can do this in the sagittal plane, I can do this in the frontal plane, I can move, rotate in the frontal plane, and I can also do a rotation about the long axis of the arm. So, a ball and socket joint allows 3 degrees of freedom. So, degrees of freedom in a joint are basically the independent motions that are possible in the joint. If you look at the only type of synovial joint that is not a rotational joint is what is known as a plane joint. A plane joint is when two bodies are moving with respect to each other in the plane. So, they slide, they glide with respect to each other, and there could be a little bit of rotation perpendicular to the plane, but otherwise it is mainly a gliding motion between the joints. Those are the only joints that have translational motion in the body. But in reality, none of the joints in the body are purely rotational. So, most of them will also have some degree of sliding and translation because of the irregular shapes of the bones. Like when you make a door and you make a hinge, you can make a hinge such that it basically allows only that rotational motion and no other motion is allowed. Okay? When you make a mechanical joint, you arrest all the other motions. In the case of the body, that is not always true, because even though, like say, the knee joint is essentially a hinge joint, it is a condyloid joint, it is actually a hinge joint, functions as a hinge joint, but you can have some degree of other motions at the joint. So, it is not a pure hinge joint as you would have in a mechanical system. The saddle joint is a very special joint, and it is really found in I think only the only location is the carpometacarpal joint of the thumb. Okay. So, it is the joint between the carpal bones and at the base of the wrist. I will show you a figure there, and that again is a 2 degree of freedom joint. So, the condyloid joint which you have is again a 2 degree of freedom joint. Then you have the plane joint, which is also predominantly 2 degree of freedoms, it can only allow sliding. The saddle joint is also a 2 degree of freedom joint, and the hinge joint is a 1 degree of freedom joint, and so is the pivot joint. So, the pivot joint allows rotation like this about the longitudinal axis. So, let us look at each of these in some little bit more closely. So, here you have the ball and socket at the shoulder. So, if you look at the upper limb, you have the ball and socket at the shoulder. Then your elbow is predominantly a hinge joint, okay, and the hinge is the hinge between the, so you have at the elbow you have 2 bones meeting the humerus. You have the humerus, you have the radius and ulna meeting the humerus, and what happens is the hinge is formed by the ulna and the humerus. So, it is the humero-ulnar joint. this is what forms the elbow joint, and structurally if you look at it, the ulna actually forms a ball and socket joint with the humerus. The ulna forms a ball and socket, structurally it is a ball and socket joint, but because of the ligaments its motion is basically restricted to a hinge type motion at the joint. So, you do not have those other degrees of freedom, even though structurally it has the ulnar head sits in a socket in the humerus. Then you have, this is the carpometacarpal joint of the thumb, and that is what allows the rotation in two different planes. That is the saddle joint that you have here. The phalanges are another example of purely hinge joints. So, if you look at your fingers, you can only bend them in one, rotate them in one direction, about one axis. Okay, you can't, the fingers, the phalanges with respect to one another you cannot rotate in other planes. So, they are hinge joints. Just to show you the structure of some of the joints. So, this is an example of the, what joint is this? This is the pivot joint. The pivot joint, and a good example of this is what is known as the joint between the atlas. Atlas is the C1 vertebra and axis is your C2 vertebra. So, this is the axis, this is the atlas. So, it is the most superior vertebra, the atlas, and then you have the axis. So, the axis has a projection called the dens, which actually, or called the odontoid process, which actually, the atlas has a cavity like this. The axis, the dens of the axis projects into this, and there is a ligament that encloses that, and it is that movement of the axis about the atlas that causes the rotation of your neck. So, the skull along with the atlas, okay, rotates about the axis, about the dens of the axis, and that causes the rotation of your neck from left to right. Okay. And this is an example of a pivot joint. As you can see, in many cases the motion is, the joint is enclosed by just ligaments, like in this case. So, this is another picture that shows the, so this is the place where the, I think I have another figure that will show you that, but your head, your skull sits on the atlas vertebrae, and that is a condyloid joint. So, you see that cavity on the atlas, and you have projections on the base of the skull like an ellipsoid joint, and that allows your rotation like this, okay, when you nod your head, that rotation, and then also the side rotation. The side rotation is slight, but the rotation about the center, about the longitudinal axis occurs about a different joint. Okay. So, you have two joints in your between the skull and the cervical vertebrae, two major joints between those two. Another example of the pivot joint. So, if you look at the arm, okay, you have, so here is the arm with your palm facing forward. Okay, this is the palm facing forward. So, in your anatomical position, this is what your palm looks like. You can see in this position the radius and the ulna are sort of parallel to one another. Now, when you do this, when you turn your palm, then the radius actually crosses over. Okay, it gets into this crossed configuration with the ulna, and that happens about an axis like this. So, if you take an axis like that, then it is pivoting about that axis, because this radius again is at, so this is the proximal part of the radius. So, that is the proximal radio-ulnar joint between the radius and the ulna, and it's got this thick annular ligament about which the radius will pivot to cause this forearm motion, this forearm rotation about the axis of the forearm. Okay, this motion is called pronation supination. So, this is the pronated forearm, palm facing forward, like you can think of it as holding a soup bowl, supination. This is a supinated forearm. So, this motion also occurs about a pivot joint, and in this case the ligament is what provides that the annulus for the pivoting. This is another example. Then this is the other joint I was telling you about between the occipital bone of the skull and the atlas C1 and the occipital bone. So, you can see that this skull pivots about that. So, that is your motion, the nodding motion of your head, and you can also, because it is a condyloid joint, it allows some rotation in another direction as well. So, again it is a 2 degree of freedom joint, and then this is your axis and it will have that projection, and the whole thing will rotate about that to cause your head rotation in the transverse plane. So, this is the atlanto-occipital joint, and it is a condyloid or ellipsoid joint. Here are, these are the examples of the ball and socket joint which function as ball and socket joints, right. So, they give you 3 degrees of freedom. You have rotation in 3 different directions. So, you have at the shoulder, for example, you can rotate in this plane, you can also rotate in this plane. So, I can rotate in the frontal plane like that, I can rotate in the sagittal plane, and although this model does not have it, but I can rotate in this plane as well. Of course, here the joint is not truly a ball and socket joint in this model, but here the control of the motion happens because of the ligaments surrounding the joint. Now, at the hip, the socket is quite deep and the ball sits nicely in the socket, and so the hip is a more stable joint than your shoulder, because the hip has to participate in weight bearing. So, that joint is more stable. At the shoulder, the socket is quite shallow and the ball sits mostly outside. You have a very shallow socket in the clavicle, but sorry, I am sorry, in the scapula, you have a very shallow socket in that, but the reason for that is you get a much higher range of motion in your shoulder joint. Therefore, it is also easier to dislocate your shoulder than it is to dislocate your hip because of this shallow socket. Okay, so these are examples of the ball and socket joint. As I mentioned earlier, the joint in the joint between the ulna, sorry, the joint between the radius and the humerus is also a ball and socket, but because of the ligaments it can only function as a hinge joint. So, we do not consider that as a ball and socket joint in function. Structurally it is ball and socket, but functionally it only functions as a hinge joint. So, here you can see you have the membrane, you have the joint cavity and the joints, they are covered by articular cartilage. All these are mechanisms to reduce the friction and make the motion smooth at these joints. This is a good picture of why the elbow is a hinge. You can see here, this is the shape of the humerus and that engages with this projection on the ulna. This is the ulna, this is the radius. And you can see this is the, has like the socket in the radius which engages with this ball in the humerus. But again, because of the ligaments together they only function as one, they only function as a hinge joint. You can see it also in this. You have the ball in the humerus and then you have this shape of the humerus which engages with this projection on the ulna, okay, and functions as a hinge joint. The elbow functions as a hinge joint. So, any rotation that happens is the forearm rotation, it is not at the elbow. So, the elbow, even though you can rotate your forearm like this, it is not technically about the elbow. The elbow is predominantly a hinge joint. The knee is another example of a hinge joint. So, you have these condyles of the knee which sit on these surfaces of the tibia, but the predominant motion at the knee is this. Okay. So, it functions as a hinge joint, it is the largest hinge joint in the body. You do have, because of the shape of the surfaces, like I said before, you know, it is not like a mechanical hinge where you arrest completely all the other motions in the joint. You do have some slight rotation that is possible and also some translation that is possible. In fact, the knee is not a pure hinge joint, okay. It is a joint with a moving center of rotation, but for all practical purposes we can treat the knee as a hinge joint. Again, your interphalangeal joints, joints between the different parts of the finger are hinge joints. Between the phalanges are hinge joints. This is the saddle joint, you can see the shape here, right, and the similarly in the other plane also, it has that kind of a curvature. That is the example of a saddle joint between the metacarpal and the carpal bone of the, at the metacarpal of the thumb and the carpal bones. Again, this allows 2 degrees of freedom. Okay. So, this is an example of the saddle joint. The planar joint, planar or gliding joint, is what you see between the bones of the carpals in the wrist and the tarsals in the foot. So, planar joint, you see it in the tarsals in the foot and carpals in the wrist. So, when the other movements are happening, these bones are gliding with respect to one another. Okay. So, that is the those are the planar joints in the synovial joints in the body. The other planar joints are the joints between two vertebrae. So, when they slide, so when you bend, like remember the joint between the vertebrae is this cartilaginous joints. So, at the in the posterior part, you can see the different vertebrae kind of interlock, they overlap with one another. Here you can see this, and the sliding motion that happens between these facets of the vertebra is another example of a gliding joint. So, again those are the few places where translation happens. As you can see, the major movements are not translational movements in the body, they are rotational motions. All the segments rotate about the joints to provide the major movements to cause the major movements of the body.